Hi guys, welcome to homework pages 3 through 5. And so I'm just going to go through a few of the problems with you, but be sure that you have your Unit 11 notes next to you when doing your homework. So a lot of this is just going to basically be review from your notes. So number 1 says, gases dissolve better in blank solvents. Well, if I look back at my notes, I know that increasing the temperature will decrease the solubility of a gas solute. So therefore, gases dissolve better in cooler solvents. Right? So temperature and the solubility of gases then have a blank relationship. Right? So since colder solvents create more solubility of gases, it will then have an inverse relationship. And I wrote increase. Inverse relationship. Alright, so basically, as temperature decreases, solubility of gases will then increase. Okay, so I then want you to go ahead and do number 2 on your own. Alright, number 3 says to circle the correct conditions below. So if you need to increase the solubility of a gas dissolved in a liquid, you should increase or decrease the pressure and increase or decrease the temperature. Okay, again, we know that if you want to increase your solubility of gas, you want to decrease your temperature. So I know for sure this one would be to decrease. And then in regards to pressure and gas have a direct relationship. So if we want the solubility of gas to increase, we then want our pressure to increase as well. And so pressure would increase. Alright, number 4. If you need to increase the solubility of a solid dissolved in a liquid, you should increase or decrease agitation and increase or decrease temperature. Okay, so if you agitate a solid, you then increase the rate of the solid dissolving, and so therefore you want to increase agitation. And in regards to temperature, well, we know solubility of a solid and temperature are directly related. So if we want solubility of a solid to increase, we want our temperature to increase as well. And so that would be increase. Alright, so I'm going to move down towards the bottom. The rest of the problems you should be able to do just by looking at your notes. But again, if you are having confusion or you need any help, do come to tutorials or ask questions in class. Alright, so number 9, why do materials dissolve? Well, we know one way that we get our solutions is our solutes are more attracted to our solvent versus the attraction to the solute itself. And so therefore our answer would be B, that the solute is more attracted to the solvent. Okay, the other answer choices would not be correct because it says the solute is not attracted to the solvent. Well, if it's not attracted, then therefore they wouldn't interact and you wouldn't have your material dissolving. Number 10. Okay, so why is the sodium ion, so Na+, attracted to the oxygen end of the water? Okay, so remember the oxygen end of the water has a negative charge, so it's partial negative, and so since sodium has a positive charge, it is then attracted to the charge on oxygen. Okay, and so why is sodium ion attracted to the oxygen end of the water? It's because oxygen has a negative charge. Alright, so with that being said, I think you should be able to do number 11 as well. And so it's just basically the opposite. Alright, down to number 12. So number 12, they want you to write 2 to 3 full sentences explaining what happens to carbon dioxide when you open a can of soda. So that is carbonation. And you need to use all of the following vocab words. Okay, so I'm not going to answer this all out for you, but I'm basically going to explain what happens. And so when you open a can of soda, you hear this like sizzle sound, and so that is the gas leaving the liquid. Okay, so we have gas that is dissolved in our liquid, and it is packaged in this high pressure, and so that's what keeps the gas staying within the liquid. Well, when you open your can of soda, you've just released a lot of pressure, and so since outside the soda is at a lower pressure compared to inside the can, the gas in the liquid basically then just escapes out. Okay, and so I think that should kind of help you with answering number 12. Okay, and again, if you're still not understanding, do come to tutorials or ask questions in class. Alright, so I am going to flip over onto page 4. Okay, so number 1, it wants us to use our solubility curve and to list 3 of the compounds that are solids. Well, remember, solids are going to be our ones that increase as temperature goes up, and they increase very quickly. Okay, so I'm just going to list one of them, and then you can go ahead and identify the other 2. And so the one I'm going to show is KNO3. And so notice how rapidly it increased as the temperature increases. Okay, so it just shoots up, and so that's one way that I know it's a solid. Alright, number 2 says to list 3 of the compounds that are gases. Well, for gases, as temperature increases, our solubility is going to decrease. Okay, so you're going to look for those lines that are decreasing. And so, for example, if I look right here, this line is decreasing. Okay, and I know you can't see what compound that is, and so it's supposed to be NH3, and so it's ammonia, and so that would be one of my compounds that are gases. Okay, again, I'm going to let you identify the other 2, but you just look for the lines that are going down as temperature goes up. Alright, number 3, how many grams of HCl dissolves at 45 degrees Celsius? Alright, so I'm going to look at the bottom, and I'm going to find 45 degrees Celsius, and then I'm going to look for HCl. Okay, so I'm just going to move up until I find HCl, and it is right here. And so then that would be 60 grams. So 60 grams of HCl dissolves at 45 degrees Celsius. Alright, and so let's just do how many grams dissolves of HCl at 20 degrees Celsius. So again, I look at the bottom. Here's 20 degrees, and then I'm just going to follow that all the way up, and my point is roughly about 72. Okay, you don't have to be precise, so if you get close in the range, you should be fine. Okay, and so numbers 4 through 5 are the same way. Okay, and then I'm just going to jump to number 7. So number 7 is just like number 6 and 8. And so number 7 says, for ammonia, what temperature is needed to dissolve 70 grams? Okay, so what I'm going to do is, here's my line for ammonia. Well, I want to go find where 70 grams is. And so that's right here. And so in order to dissolve 70 grams of ammonia, our temperature would then have to be at 10 degrees Celsius. Okay, so let's see what temperature it needs to be in order to dissolve 55 grams. Well, here's my line for ammonia. So 55, if I follow that up, it's right here. And so bring that down, and that would be at 20 degrees Celsius. Okay, so you should be able to do number 6 and 8 just based off of problem 7. Alright, so number 9, we need to match. So if we have unsaturated solution, our unsaturated solution is going to be our solution which can still take in more solute. Okay, so that would be C. So C can take more solute. Alright, saturated solution, it's holding the maximum solute that it can hold. So that would be A. While a super unsaturated solution can hold extra solute, so it can still take more in, and so that would be B. So it's holding extra solute. Okay, and then at the bottom from questions 10 through 16, you just have to indicate if it's saturated, super unsaturated, or unsaturated. And so I'm just going to do 3 of them for you, but I think you should be able to do these fine just as long as you follow your notes. So number 10, extra solute will settle at the bottom because the maximum saturation point is already reached. Okay, well that's going to be saturated. Okay, so remember saturated, it holds the maximum solute that it possibly can, so it can't take in anymore. 12, a pinch of salt added to a bottle of water. Okay, so that's going to be unsaturated, and so it can still take in more solute. It's just a pinch of salt, so not all of the water molecules are being used up. And then last, 16, more solute could still be dissolved in the solvent at a given temperature. So that would be super unsaturated. Okay, so it holds extra solute. Alright, so I'm just going to go ahead and flip over to page 5. Okay guys, so back to looking at our solubility curve. So number 17 says which materials have the same solubility at 71 degrees Celsius. So what I'm going to do is I'm going to find 71 degrees Celsius, and I'm just going to go all the way up until I get to a point where I have 2 lines that are intersecting. Right, and so therefore I know that KCl and K2Cr2O7 both have the same solubility. Okay, so again, I'll just go ahead and do the same thing for 23 degrees Celsius. So I'm going to find 23 degrees Celsius, and I'm just going to go up until I find where 2 lines intersect. And then, so I have potassium chloride. Okay, so those are my 2 compounds that have the same solubility at 23 degrees Celsius. Alright, so go ahead and try to do that last one on your own. Right, number 18 says which compound is most soluble at 10 degrees Celsius. Okay, so I go to 10 degrees Celsius, and the way you find out which one's the most soluble, it's the one that has the highest amount of grams that is produced. So if I go all the way up, that's going to be my compound that is most soluble. Alright, number 20. If 30 grams of this compound is dissolved in 100 milliliters of water at 70 degrees Celsius, is it saturated, unsaturated, or super saturated? Alright, so if it is saturated, if we go and find where 30 grams is and 70 degrees Celsius, if we find where that is in our graph, that point, if it is on the line, it will be saturated. If it is below the line, it will be unsaturated. But if it is above the line, it will be supersaturated. Okay, so let's just go ahead and find out. So I have 30 and 70. So I go, see where it crosses, and that is the compound that I was looking for, and so it's right on the line. And so since it's on the line, it will be saturated. Okay, so I'll let you go ahead and try number 21 on your own. Okay, number 23 says at 10 degrees Celsius, if 20 grams of this compound is dissolved, would the solution be unsaturated, saturated, or super unsaturated? Okay, so it says at 10 degrees Celsius and 20 grams. So let's go ahead and find where that would be. And so that's going to be right here. Well, it's right on the line. This is the compound that I was looking for. And so then that would be saturated. Alright, let's go ahead and do number 24 together. Alright, if we have 10 degrees Celsius and 92 grams, if I follow that and see where the point would intersect, it's way up here. Well, the compound that I'm looking at is the lines here. And so if my point's up here, but my line for that compound is right here, it's way above the line. And so therefore, it would be supersaturated. Alright, and then number 26, it says, for this compound at 70 degrees Celsius, how many grams would dissolve to make a saturated solution? Okay, so I'm going to find that compound, and it says at 70 degrees Celsius, how many grams would dissolve to make a saturated solution? Well, again, it'd have to be right on the line, and so if this is right on the line and I follow out to the left to see how many grams, that would be 30 grams would dissolve. Okay, so I hope that was easy to follow. If you are still confused, just stay after school or come to tutorials. And so last, I'm just going to jump to the very bottom. And so at the bottom, we are going to be using this table to answer the questions. And so number 27 says, which material solubility is least affected by temperature? Alright, so the way that you determine which is least affected, look at what the temperature is when it's at a higher temperature and compare it to, look at the amount of grams at a higher temperature compared to the amount of grams at a lower temperature. And so just look at the difference. And so it says least affected. Well, for substance A, it went from 22 grams all the way to 84. Well, that's a pretty big jump. And so I would say that that was really affected by temperature. And so, but let's go ahead and keep on looking at the other substances. So substance B, it went from 20 to 49. Okay, well that's somewhat of an increase, but it's not compared to substance A, which has this huge difference. Okay, let's look at substance C. Well, it went from 31 grams to 43 grams. Well, that's a lot less than substance B or A, so it's possible that that might be my answer. And so let's look at substance D last. And so we went from 50 grams to 12 grams. Well, we had a decrease in the amounts of grams that were produced, and so therefore that's the bigger difference. And so C would be my answer for the one that was least affected by temperature. Okay, so how do I know? Again, I just looked at the difference. So if you look at where you started, so when it's at a lower temperature compared to when it's at a higher temperature, you can determine how temperature affects the solubility of the substance. Okay, and so I think you should be able to answer 28 on your own. And then 29, it says, which of these substances is most likely to be a gas? Remember, gas has an inverse relationship with temperature. So as temperature increases, you should expect to see your solubility of gas decrease. And so I think with me telling you that, you should be able to answer 29 now. Alright, so again, if you have any questions, if you're still confused, or you need extra help, just come in for tutorials or make an appointment to stay after school. And yeah, so have fun finishing your homework, and I will see you next time.